Welcome to the Explainer. Today, we're diving into a really cool coding problem, how to build a tournament bracket from the ground up. We'll take a group of teams and, using a surprisingly elegant method, map out the entire competition. Okay, so picture this. You've got 8 teams, and they're ranked by skill, from the very best to, well, not the best. How do you actually write a program to simulate the whole tournament? The main rule is pretty simple. In every single round, the strongest team left plays the weakest one, until there's only one champion standing. And the way these matchups are set isn't just random. The whole idea is to pair the strongest team with the weakest. So team number 1 plays the last ranked team, number 2 plays the second to last, and so on. It's all about trying to save those really big, exciting showdowns for the later rounds. So what's the actual challenge here? It's not just about figuring out who wins. It's about how we represent the entire tournament, the whole journey, in a very specific way.
Right, so the goal here is pretty unique. We're not just trying to find a champion. We're given a number of teams, let's say N, and our job is to spit out a single long string. And this string needs to represent every single match, from the first round all the way to the final. Think of it like we're building the entire tournament bracket, but purely with text.
Okay, before we jump into a full-blown 8-team tournament, we really need to wrap our heads around this weird string format. So let's start small with just 4 teams and see exactly how this thing gets built. So for 4 teams, this is what we're aiming for. Now, I know, at first glance, it just looks like a bunch of parentheses. But trust me, there's a really clear logic here that perfectly maps out the whole tournament. So how do we read this? Well, you've got to think from the inside out. The innermost pairs, 1-4 and 2-3, those are your first-round games. Then, see that outer set of parentheses? That wraps around the first 2, showing that the winner of 1-4 is going to play the winner of 2-3. That's the final match. Okay, now that we get the 14 version, let's scale it up. We're going to walk through an 8-team tournament round by round. This is where the pattern really clicks into place, and you'll see just how powerful this simulation approach is. All right, round 1. We start with a simple list representing our 8 teams. We're going to treat them as strings right from the get-go. 1, 2, 3, and so on. This just makes things way easier down the line, since our final output has to be a single big string anyway. And boom, round 1 is done. We just apply that pairing rule. 1 plays 8, 2 plays 7, 3 plays 6. You get the idea. So now, our list of 8 teams has transformed into a new list of 4 matchup strings. These 4 strings are basically our new competitors heading into round 2. And here is the really cool part. Those 4 strings we just created, that's our input for the second round. The teams are no longer just numbers. They're the entire match history that got them here. And we just apply the exact same pairing logic all over again. So the first element, 1,8, plays the last one, 4,5. The second plays the third. And just like that, we're down to 2 finalists. You can see how the strings are getting bigger and more nested, right? They're literally telling the story of how each winner got to this point. Okay, here we go. Round 3. The grand finale. We've got our 2 remaining competitors ready to face off for the championship. This is the last step. And there it is. We pair those last 2, and the simulation is complete. We started with 8 separate items in our list, and now we're left with just 1, a single super nested string that holds the entire history of the tournament. Pretty neat, huh? All right, so walking through it step by step makes sense. But how do we generalize this? What's the actual algorithm we can write to do this automatically for any number of teams? Now, this is probably the most elegant part of the whole solution. Instead of creating a brand new list every single round, which, would take up extra memory, we do something smarter. We actually overwrite the first half of the list we're already using with the new match results. Then we just tell our program, hey, for the next round, only look at the first half of this list. It's an in-place modification, and it's super efficient. The magic behind the pairing is this idea of 2 pointers. Basically, you have one pointer starting at the beginning of the list, at index I, and another one starting at the very end at index n-1. In each step, they pair up the elements they're pointing to, and then they both move one step closer to the middle. They just keep doing that until they meet. And this whole thing just keeps repeating. After every round, the number of competitors gets sliced in half. We go from 8 to 4, then 4 to 2, and finally 2 to 1. The loop only stops when there's just one item left, our champion string. Okay, so now that we've really broken down the logic, the actual code should look, well, a lot less intimidating. Let's see how this all translates into some simple Python. And look at that.
Every single step in the code maps directly to what we just did manually. Step 4, that's our two-pointer pairing logic. Step 5 is where we shrink the problem size for the next round. And the whole thing is wrapped in a loop that keeps going as long as n is bigger than 1. It's a perfect one-to-one translation of our strategy. This whole two-pointer approach, starting from opposite ends and meeting in the middle, it's not just for tournaments. It's a classic, super useful pattern in programming. You could use it to see if a word is a palindrome, or to find pairs of numbers in a sorted list that add up to a target. So the real question is, where else have you seen this? Or where else could you use it? It's a great little tool to have in your back pocket.